Hello students, this video is about graphing the tan function when you have transformations in them. For example, one thing we already know is that this graph has been shifted, it may have been shifted to the right, and it may have a different period than a regular tan function. But one thing is true about all tan functions, it creates this shape, like this, where the middle point is usually the x-intercept, unless it has a vertical shift in it. And then you have one increment to the left, where at the y value you meet typically the amplitude, and then one increment to the right is going to meet the amplitude as well in a different direction. Whatever the a value was to the right, it may be going upwards that far, and to one unit to the left, it may be going down that far. All right, so let's put all that to use. So before I ever even graph this function, let's decide all the important information that's given us out this equation that can help us graph it. So the first thing I have is a, which is usually amplitude, but tan doesn't really have an amplitude because it doesn't stop going up or down. So we're going to use it to find the first increment to the right and left of how high it goes. And then b is still going to be 2. And then c is going to be, in this case, I'm going to just call it whatever that sign says. C is going to be pi over 4. So I'm going to call C pi over 4. And then d is, of course, going to be 3. So before I actually get to graphing, let's decide what all these things are. If I know b is 2, I can find my period. So the tan, the period should be pi, but it's going to be pi divided by b. So in this problem, my period is pi divided by 2. Where I start at, which is my first x-intercept, is going to be negative c over b. This is going to give you negative pi over 4 divided by b, which is 2, which reduces to be negative pi over 8. I call it my start. With tangent is also the first x-intercept. I'm going to put this one in quotations because it may not really be the x-intercept if you got a vertical shift. But in the parent function, it would be the first x-intercept. The parent function, that's if the tangent was not shifted at all, would be the first x-intercept. The next thing I need to know are my increments. So my increments, basically the period over 4, so increments equals to your period over 4. So in this case, since my period is pi over 2, and divide that by 4, so my increments are pi over 8, meaning each new step in the curve is pi over 8 to the right of the last. So that's what that's telling me. So that's the characteristics I'm looking at there. And while we're at it, let's go and find out what each of those steps are. As in, when I actually graph it, let's figure out what each of these numbers should be. So when I actually graph this function, let's figure out what each of these steps, I'm calling that step 1, step 2, step 3, step 4, step 5, and so forth. That may not actually be step 1, depending on where the starting point is. But that's the idea. We want to find out what those numbers are. Where we're going to find that is, we use our start. In this problem, the start was at negative pi over 8. So we take that place, which is negative pi over 8. I'm going to add an increment to it. So I'm going to plus one increment over, which is pi over 8. Alright, so that's going to be 0. So step 1 is 0. That's my first step. So I started at negative pi over 8. I'm going to call that negative pi over 8 right here because it's on the negative side. One step over should be at 0. Here's 0. So this is step 1. So step 1 is 0. And then step 2. All right, so step 2. This is going to be 0 plus another increment, which is pi over 8, which is a nice friendly number, which is pi over 8. So the next number over is pi over 8. Step 3. It's going to be pi over 8 plus another increment over, which again is pi over 8. So that's pretty easy. 1 pi over 8 plus another pi over 8 is 2 pi over 8. That could reduce to pi over 4, but I won't bother. I'm going to leave it like this. It's going to be 2 pi over 8. I said enough to see the pattern. It's going to be 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, and so forth. I got a lot of increments here. I got more than 4 of them, which is a great place to start. So I know what the function is going to look like because I've graphed a bunch of these. But before I actually try to graph it, instead of just graphing it using the pattern I know for tangent, let's make a table. Let's use these increments to come up with a table. So the increments were negative power of 8, 0, the steps were negative power of 8, 0, power of 8, 2 power of 8, 3 power of 8. So I'm going to make an XY table. And after you get really good at it, at some point you can kind of see what it's going to do without a table. But I think to understand it for right now, having a table is a good place to be. So this is X and this is Y. So the first coordinate is going to be my starting point. This is my start, which is negative power of 8. The next coordinate I'm going to find using my step 1. So step 1. So one step over was at 0. The next step over was power of 8. The next step over was, okay, here's the power of negative power of 8 is 0, power of 8. So the next steps are 2 power of 8, 3 power of 8, 4 power of 8, and 5 power of 8. All right, so I want to fill the rest of my table with all other increments. And I wrote the equation that we began with. And my first thing I want to do is I'm going to plug in negative power of 8 to get the output. So I took out my calculator. I typed it in. Depending on the calculator you have, you got to put it in radians mode. My calculator is pretty easy to put in radians mode. It's 8 degrees. It makes your radians in black. But you might have to put yours in radians mode. Then after do that, type it all in, all the way to the 3 at the very end. You should get the first output is 3. So here the first output is 3. All right, so I'm going to do the same thing. I'm going to plug in 0. I'm going to plug in power of 8. I'm going to plug in 2 power of 8. All into this equation where the X was. I'm going to write my outputs here. All right, so when I plugged in 0, I got an output of 6. When I plugged in power of 8, I got an output of undefined. So it doesn't exist there. When I plugged in 2 power of 8, I got an output of 0. If I plug in 3 power of 8, I have an output of, got an output of 3. If I plug in 4 power of 8, had an output of 6. When I plug in 5 power of 8, I got undefined again. So I can see the period now. I've done enough to see where it starts to repeat itself. So I'm going to take these values, I'm going to apply each of these coordinates on the original axis. So the original axis at negative power of 8, the output was 3. 3 right here. So negative power of 8, this is the output. At 0, the output was 6. So 4, 5, 6. So at 0, the output was at 6. At power of 8, it was undefined. So I'm putting an asymptote there because it doesn't exist at power of 8. At 2 power of 8, the output was 0. So at 2 power of 8, I'm going to make sure it touches the axis. At 3 power of 8, the output was 3 again. At 4 power of 8, the output was 6 again. At 5 power of 8, it was undefined again. So I see enough to see that on this side, it's doing this shape. So the asymptote is right here. On this side, it goes through the 6. It must asymptote another end. If I put another increment over, it'll probably cause that 0 there. And it'll asymptote in the next increment. So I see enough to see the pattern and have this full shape of it. So this is 2 periods of that sine curve, given that information. And we did it with the table of values. Now, I can see my midline is right here at 3. And you can tell that by the equation, because I had a plus 3 there on the end. I see that's been shifted over to the right power of 8. That's my first x-intercept, quote unquote x-intercept, because it's been shifted up. It's not really that. But that's how equation graphs. We use all the information to actually graph it. All right, let's graph one more of those, and hopefully you can kind of start seeing how to find A, B, C, and D, the starting point, the period, the increments, using those increments to come up with other steps, then actually graphing it. And after a few, I hope you start seeing the pattern. Let's go to a new one now. All right, so this is the final one. I made sure this, in this case, A is -3. So instead of the tan curve looking in this direction, which is positive 10, I know by making it negative, it's going to look reversed. You can have all the characteristics of 10, but it's going to be reversed. So I know A is negative 3. I know B is 4 pi. I know C, there is no C. So if I was to write a C, it must have been 0. So it'd be 4x plus 0 added to the end. So C is 0. There is no D either, because if there was a D, it'd be a number to the end. So the number added to the end must be 0. So D must be 0. So you saw all the letters be 3, tan of this, where you can see A, you can see B, you can see C, and you can see D. But this didn't have the C and D. All right, so with that said, the next thing you need to start. So you should start, or your first x-intercept should be negative C over B, which is going to be negative 0 over 4 pi, and that's 0. My increment, well, first of all, my period, you need that first. So my period is going to be pi divided by B, which is 4 pi. So it's going to give you, well, pi divided by 4 pi. Pi's cancel, give you 1 over 4. So my period is actually a whole number this time. My period is 1 over 4. There's no pi's in it. So here's my period is 1 over 4. And then the next thing, my increments. Increments here is going to be period over 4, which is 1 over 4 over 4, which is 1 over 16. So now my increments are 1/16. And the steps. So I'm going to take my start, which was at 0, and then step 1 should be at, this is step 1, should be at 0 plus 1 increment, which is 1 over 16, which is 1 over 16. Step 2, or the second number in my table, should be 1 over 16 plus 1 over 16, which is 2 over 16. And I see the pattern already. Pretty easy when you go through 0. So the next increment over is going to be 2 over 16 plus 1 over 16, which is 3 over 16. So I know the next number at step 4 is going to be 4 over 16. And then 5 over 16. So it's going to be 4 over 16. So I can go and graph that. I know that my first start is at 0. The first number over to the right should be 1 over 16, 2 over 16, 2 over 16, 3 over 16, 4 over 16, 5 over 16, 6 over 16, and so forth. And I just went 1 to the left of my starting place because tangent always splits. Like it has half of it on one side and half on the other. So I just went 1 number to the left. I could have went 2 over. I'm going to go 2 over. I already know what they're going to be after I see my pattern. I'm going to go 2 to the left as that as well, so I can see the asymptote. All right, I made a table with that information. Here's the table I created with those increments. I didn't put the negative 2 over 16, but I got enough there to actually come up with the table. I'm going to plug in negative 1 over 16 into the function. I should get an output. And if I had to take a guess, on one of the bets, it's going to be 0. Let's make sure. So actually, at negative 1 over 16, output is at 3. When I take that same equation, I plug in 0, the output should be at, when I plug in 0, the output should be 0. So the next number over is 0. When I plug in 1 over 16, the output is at negative 3. So I'm going to negative 3. I'm willing to bet this is going to be an asymptote. I'm going to make sure though, by plugging in a 2. So when I plug in 2, I get undefined, exactly what I expected. So at that place it's undefined. I've seen enough to know the pattern is going to be. It looks like it's going to be, well, let me go one more number over this, just make sure. When I plug in 3 over 16, the output was 3. 4 over 16, I want to bet the output 0. I'm just going to go over and make check. Plug in 4 there. Output is 0. 5 over 16 is probably should be at negative 3. Just make sure. Plugging in 5 there. And there it is at negative 3. I see enough to figure out the pattern to finish graphing it. So let's graph it. Alright. So in that table, the first number we chose is negative 1 over 16. It goes 3, 0, negative 3 undefined. So this is my first one. It should be at 3. The next one should be at 0. At 1/16 should be at -3. And then it was undefined at the next step over. The next step over is at 3 again. And then it was at 0. And then it was at -3. There's undefined next step over. So for that matter, if that's at 3, what came before that must have been undefined. So if I connect the dots through here, it goes down through this number. And there's one period of it. Do the same thing again. There's a second period of it. So I got 2 periods of the tan function. And that's it. That's how they work. Hopefully, you see that there's several parts to graphing the tan function. But basically, if you start to see the pattern of it creates a number on the midline, 1 unit to the left, it goes up by A, and then 1 unit to the right, it goes up by A, depending wherever A is. If it's negative, 1 unit to the right, it goes down by A. If it's positive, 1 unit to the right, go up by A. So whatever A is, if it's negative, like I said, it goes 1 unit to the right, it goes down that far. On the left, it goes to reverse. And then asymptotes is going to be basically 2 steps to the right. If you found the proper increments, it should be 2 steps to the right, whatever that x-intercept was, or the number that's quote unquote the x-intercept. Because if it's been shifted up, it's not really the x-intercept. But I hope that helps. Still got more questions. I can make more videos like these explaining how to actually find each of these values of x and come up with a table to come up with it until you start to see the pattern without having a table. All right, that's all I have. Good luck.